Okay, start recording. And today we will continue with S2, chapter 5. Okay, so chapter 5 is about hypothesis testing. Okay, there are a few types of questions that we're going to discuss accordingly. Okay, so we're going to look at a general procedure, a binomial, okay, binomial lesser than, binomial greater than, binomial not equals to, Poisson lesser than, Poisson greater than, Poisson not equals to, sample mean lesser than, sample mean greater than, sample mean not equals to. So as you can see, sample mean is just the reason, the distribution that you have learned. Okay, then we will discuss more about type 1 and type 2 errors, and we will also talk about a probability of type 2 errors here. Okay, so we're going to discuss type by type. Okay, adjacent. So from the past, okay, the what kind of distribution that you have learned? You have learned about general discrete, discrete uniform, binomial, normal, Poisson, general continuous, continuous uniform. When it comes to further maths later, we will have more distribution to discuss about. Okay, so whatever that we're looking here is only up to S2. Okay, but regardless whether S2 or further maths or further statistics, the procedure is the same. Okay, you have a general procedure. Step 1, identify correct distribution. So correct distribution here, it will be important. Okay, so if you recognize the distribution wrongly, then will be, of course, it will be wrong. Okay, with the correct parameter, respect to a different distribution, you have a different consideration that we have to take into account. Okay, 2, write null hypothesis and alternative hypothesis. This one is according to what the questions want to test. Okay, and usually the theta naught here is what we claim. Okay, this is what we claim. So alternatively, okay, there will be a lesser than, there will be a greater than, there will be a not equals to value. So we will be, the alternative, we have 3 cases that we actually need to take into account. Okay, then after that, identify significant level alpha and evidence. Okay, the evidence here we will use letter M. Okay, from the questions. So usually this information will be given. So you will actually see accordingly when we discuss about question by question, how do we actually use this information. Okay, number 4, we're going to do calculation. We have 2 methods here. We have a p-value method, okay, or the critical value method. For your syllabus, you are required to know both. Okay, for your syllabus, because sometimes certain type of question can only use a certain method. Okay, some question can only use p-value method, some question have to use the critical value method. Okay, so this will be the reject condition. Okay, so we will reject H no. Okay, H no is what we have here, H no. Okay, if probability of theta lesser than theta naught lesser than alpha. Okay, for theta lesser than theta naught. For if probability of theta greater than theta naught lesser than alpha. Okay, if we have this, so sorry, I think I wrote something wrong here, because that's evidence, right? Lesser than evidence. Okay, there should be M here. Okay, again, reject condition. Okay, if the probability of theta lesser than the evidence is lesser than alpha. Okay, for theta lesser than theta naught. Okay, if theta greater equals to M for greater than lesser than alpha, for the theta lesser than theta greater than theta naught, or the 2 cases. Okay, the 2 sides. Okay, not equals to, you can be either or here. And what does it mean by the alpha here? Is the error that we can afford. Okay, that we are affordable. Okay, so that means if let's say what is the best way to actually understand alpha? Let's say we are Proton produce cars versus Mercedes produce car. Let's say produce the after Proton produce one batch of car, Proton say, okay, as long as the 95% of the cars are in good conditions, okay, you can actually release to the market. Okay, how do they actually do 95%? 95% is actually they do by sample, they do by test. Okay, so it is a 95% level. Okay, that means they will allow 5% of error. So then if let's say compare to a Mercedes, okay, Germany car, so they say, okay, must be 99.9% that is in good condition, then only you are allowed to release this batch of car to the market. And that means their margin of error is actually very small, only 0.01%. Okay, of course I don't know about the actual value, but this is just how the concept will be. Okay, so is the alpha here is the error, the amount of error that you are allowed. Okay, so then after that, number 5, you have to make conclusions. So over here, it's better for us to look at how to actually do the questions from the step of 1, 2, 3, 4, 5. Here, let's say for the first question, okay, so probability of P, okay, there's a P here. P is probability of success. Okay, so this one we are talking about binomial. We are talking about binomial. Okay, binomial we have 3 types: a lesser than, greater than, not equals to. Let's see which one is it. This is binomial greater than. Okay, this is binomial greater than. Binomial greater than. Okay, so let's see how do I do. So number 1, okay, step 1. Identify the correct distribution. Identify the correct distribution. X is binomial distributed with n equals to 10, 10 and p. So the p here is what we're actually testing. Therefore, when we looking at the distribution, we don't write it out. Okay, we don't write out the number. Then number 2, what is the step 2? Step 2, we will look at write out the correct hypothesis. Okay, null hypothesis and the alternative. So usually you can actually see it from your questions. So over here, H null is testing P equals to 0.25. Okay, versus H1, P is greater than 0.25. So we're actually testing whether the probability value is greater than 0.25. Okay, then the x equals to 5 here is your evidence. Okay, and the 5% is alpha. So step 3, okay, step 3, identify significant level, alpha, and the evidence. So over here, we will say that the alpha equals to 0.05, the m equals to 5. Okay, the evidence m equals to 5. So then after that, number 4, okay, you have to do calculation. Okay, so before we actually do our calculation, either p-value method or critical value method, write out the reject condition first. Okay, this is like a training for students. Okay, number 4, calculation. Okay, then we have the reject condition. Reject condition. Because it is binomial greater than, so reject H null if P of P of X here, this one X, is greater equals to 5, lesser than 0.05. You can see that this value 0.05 is come from here. This 5 is actually equal to this. Okay, so we continue with step 4. We have a p-value method. Okay, p-value method. So I put probability of x greater equals to 5. Okay, for px equals to 5, so over here you can actually use your manual calculation. Okay, you can use a p of x equals to 5 plus px equals to 6, all the way to px equals to 10, because you have up to 10 here. Or you can use complement method, 1 minus p of x lesser equals to 4. Okay, of course, by using calculator, you are allowed to, you can actually get the value of x lesser equals to 4. Okay, so go to distribution binomial CD 1, okay, then list and variable, so we do for a variable, x equals to 4, n equals to 10, p equals to 0.25. Okay, so I have a 1 minus 0.9218730.926. Okay, so I just press my calculator. I have 1 minus 0.9218730.926. So I have a 0.078. Okay, so as you can see, what do we say here? Reject H no if this. So this one is is not lesser than 0.05. It's not lesser than. So what conclusion do we make? Do not reject H no. Okay, usually when you write the condition, when you write the conclusion, you have this part, 1 mark, then you have another mark that you have to write the context of the questions. Okay, so this is how we actually can use p-value method. Okay, so now we look at critical value method. Critical value method. Okay, for critical value method, let's see. Okay, from the reject condition, okay, from the reject condition, we are looking for the critical value, okay, the C here, critical value that lesser than 0.05. So I can actually use my calculator, okay, from calculator, maybe I can do, okay, p of x lesser equals to 4, p of x lesser equals to 5, p of x lesser equals to 6. Let's see what do we get. Okay, so distribution binomial CD, okay, variable list, maybe I go for list. Okay, list, I press 4 equal 5 equal 6 equal, then 10 and 0.25. So I have the value 0.9218, 0.9802, 0.9964. Okay, in other words, this one is lesser equals to. That actually give me p of x greater equals to 5 is 0.07 1007 1 minus 0.9218982. Okay, then this one give me p of x lesser equals to 6 equals to 1 minus 0.9802. I have a 0.0198. This one gives me p of x greater equals to 7 equals to 1 minus 0.9964. Okay, so you have a 0.0036. You will see that the critical value here, the C that we're trying to find, okay, using green color, the C that we are trying to find is actually this. Okay, it's actually this. So from here, we managed to get the critical value equals to 6. Then after that, what do we do with this critical value? Okay, we draw a number line. We label 6. Okay. this is greater than, this one is greater than, so on greater than, that means greater than 6 we reject H no, or lesser than 6 we do not reject. Okay, then observe the locations of evidence. The evidence equals to 5, so the evidence is 5, m equals to 5, therefore do not reject H no. Okay, so of course, for those who always say, I want to know why this and that, okay, so this may be quite difficult for you in the sense that at the moment you are not required to know the reason, or you are required to know the procedure. Okay, you are required to know the procedure. So you have to ask yourself, don't be stubborn here. I know that some of you are actually stubborn. Okay, want to know why. I only have one questions to you, or only have one instruction to you. Can you follow the steps? Okay, can you do the 2 methods? That's all. Okay, so let's look at more questions. Okay, let's look at more questions. Let's see first. Wait, I'm looking for my thing here. Okay. Okay. So right here. Okay, so we already seen one example, so we're going to look for more. Okay, so this is binomial lesser than. Binomial lesser than. Okay, so number 1, step 1, x is a binomial distributed with n equals to 10 and p. Number 2, we write h no, p equals to 0.4. h1, p is lesser than 0.4. Number 3, okay, I have alpha 1 and 5, so alpha equals to 0.05, evidence equals to 1. Then number 4, okay, reject h no if p of x, this one is lesser than, so I put lesser than, this is m, evidence, okay, is lesser than 0.05. Okay, this is the reject condition. Then p-value method. Okay, p-value method, I calculate p of x lesser equals to 1. Okay, so you have p of x equals to 0 plus p of x equals to 1. Okay, apply your binomial formula. So go to distribution, binomial CD. Okay, variable x equals to 1. Okay, n equals to 10 and p equals to 0.4. So you have a 0.046. Of course, this is lesser than 0.05. Therefore, we reject h no. Reject h no. Okay, so if I want to do the second method here, okay, critical value method. Okay, critical value method. Then over here we will have this one. I want from the reject condition. Okay, so P of x lesser equals to C lesser than 0.05. Okay, so I press with I use my calculator from calculator. Okay, so P of x lesser equals to 0, P of x lesser equals to 1, P of x lesser equals to 2. Let's see, I try for this value. Okay, menu, distribution, binomial CD, list. Okay, so I press 0, 1, 2. Okay, 10 and 0.4. So I have a 0.006. Okay, 0.0463, 0.1672. Okay, by looking at the critical value, you should see that the critical value equals to 1. Okay, critical value equals to 1. You will see that this part of writing here and compared to the top is not is you actually skip one step. Is because this one is greater than, this is smaller than. So when you use your calculator immediately give you the value of the smaller than, so it's easier. So from the number line you have 1. Okay, that's your critical value. Okay, according to your hypothesis. Okay, this is to the left. Therefore, this is the part where we reject H no. This is the part that we do not reject. Okay, the evidence itself is M. The location of the evidence is 1. Okay, M equals to 1. Therefore, because it's 4 on the dot, okay, it's 4 on the dot, therefore we reject H no. Okay, which actually fit with our reject condition. Okay, which fits with our reject condition here. Okay, so for practices, just make sure that you actually write out the reject condition properly. Okay, next, let's go for more. Okay, then after that, let's go for a two-tail. Okay, next let's go for a two-tail. So this binomial not equals to, binomial not equals to. Okay, we call it two-tail because it can be from the left and from the right. Okay, so over here, let's write out the steps. Step 1, x is a binomial with 30 and p. Okay, then 2, we have the hypothesis. Okay, it's a p equals to 0.5. Okay, h1 is p not equals to 0.5. Okay, so 3, so the m equals to 10 and alpha equals to 0.05. Number 4, okay, we need to write out the reject condition. So the reject condition now, if you actually can refer back to the notes, so now there is alpha over 2. Okay, there's alpha over 2 that you need to take care. So reject H no if P of x lesser equals to m, okay, lesser than 0.05 over 2, or P of x greater equals to m lesser than 0.05 over 2. That will be the reject condition that we have. Okay, then the p-value method. Okay, so we can actually do P of x lesser equals to 10. Okay, So press calculator, binomial CD, okay, variable x equals to 10, okay, n equals to 30, p equals 0.5. So I have a 0.049. Of course, it's not lesser than 0.025. P of x greater equals to 10. Okay, equals to 1 minus p of x lesser equals to 9. So 1 minus, let's see, 9 here. Okay, 0.0214, okay, equals to, okay, 1 minus 0.0214. So we have a 0.9786, which is not lesser than 0.025. Of course, from here is, okay, both rejected. So we have a do not reject H no as your answer. Okay, now comes to critical value method. Critical value method. Okay, this time I have two items to actually take into account. Okay, so I have p of x lesser equals to c1 lesser than 0.025 and p of x greater equals to c2 which lesser than 0.025 that we have to take into account. Okay, so that means we need to use whatever that we have. Then we can actually use the table. Okay, so C1 and C2. Let's see what do we have. I use binomial CD. I go for the least. Okay, maybe this time this is 10. Okay, 9 0.025. Okay, I have maybe okay, so 8, 9, 10. Okay, 11. So maybe 21, 20, no, not 20, 20 maybe I have 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, so let's see from here. What do I get from the working? So what I obtain from the calculator is p of x lesser equals to 9, give me 0.0213, okay, lesser than, then all the way I have let's see, 1 minus 0.9786, okay, 9786. So also give me p of x lesser equals to 20, give me 0.9786. That actually give me p of x greater equals to 21 equals to 0.0213. That actually fulfill the two conditions here. This and this. My C1 equals to 9, my C2 equals to 21. Then I draw my number line. 9 and 21. Okay. Then from this 9 and 21 here, okay, how do I actually determine the reject region, do not reject region? From the two end side, they are the reject. The middle is the do not reject. Okay. So then we observe the evidence. The evidence is 10. The location of the evidence is here. M equals to 10. Therefore, therefore we do not reject H no. Therefore, we write do not reject H no. Okay. Okay. So I believe from here you already seen three types. Okay, binomial greater than, binomial lesser than, binomial not equals to. Okay. So from these three examples that I actually show you, okay, there are two items that we actually want to discuss. Okay. So number one, okay, actual significant. Okay, we ask these questions. We ask these questions, okay, when it's been rejected. Okay, if rejected H no, then we continue to ask these questions. Okay, then from this question, after we rejected H no, the actual significant is the value that make it reject. So from the second example here, okay, from the second example here, you can see that we reject H no, okay, from 0.0463, okay, 0.0463. So this is the actual significant, okay, 0.0463. Okay, then question number two that we want to ask, it will be the, what is it called? Critical region. Okay, critical region. The second question that we want to ask is critical region. The interval of x to reject H no. Okay, this back to question one. This one is from question two. Okay, the second, okay, critical region, interval of x to be reject H1, the H no. So question one, we have the interval of x. From question one, we have interval of x. The reject region is 6. Okay, starting from 6, so until 10. So reject region is x equals to 6, 7, 8, 9, 10. Of course, most of the time we actually write like this, 6 to 10, where x is an integer. Okay, for question 2, there are critical region. This is 1, okay, 0 and 1. You only have 0 and 1. X equals to 0 and 1. For question 3, okay, you see that there are two end part. Okay, you have two end part. So the x value will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then continue from 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay. Of course, most of the time we don't write like this. We will just write x is elements of 0 to 9 union 21 to 30. So x is a natural number. We can actually write in this way. So in other words, whatever the numbers I list out here, as long as the the evidence, okay, the number of evidence fall under these numbers, okay, then it's already good enough to reject the H no. So this is called critical region. Okay, I let you practice this part first. Okay, I'm not going to ask you to do a lot. Okay, so that you actually get used to the 5 step at first. Okay, let me post some questions here so that you can practice. Okay, if possible, you also write out the actual significance and the critical region. Okay, for any questions that are applicable. Okay, that's all for today. Thank you very much.